In this video, we will learn how to find the probability that among several trials, we get at least one of some specific event, and we will also learn about conditional probability. When finding the probability of some event occurring at least once, we should understand the following. At least one has the same meaning as one or more. The complement of getting at least one particular event is to get no occurrence of that event. Let's look at the steps involving finding the probability of at least one. At some point, you might want to stop the video and write down those steps in your notes for further references. Understanding the procedure can help you greatly with solving the problems involving this concept. First step is let A get at least one of some event. Step 2, then A bar, the complement of event A, would be getting none of the events being considered. Step 3, find the probability of the complementary event, the probability that event A does not occur. Step 4, subtract the result from 1. That is, evaluate this expression. Probability of at least one occurrence of event A is equal 1 minus probability of no occurrence of event A. Let's do the following example. A study by SquareTrade found that 6% of damaged iPads were damaged by bags or backpacks. If 20 damaged iPads are randomly selected, find the probability of getting at least one that was damaged in a bag or backpack. To solve this problem, we'll apply the steps we went over earlier. Step 1. Let event A be at least one of the 20 damaged iPads was damaged in a bag or backpack. Step 2. Identify the event A bar that is a complement of event A. A bar is not getting at least one iPad damaged in a bag or backpack among 20, which is equal to all 20 iPads damaged in a way other than bag or backpack. Step 3. Find the probability of the complement by evaluating P of A bar. P of A bar is equal P of all 20 iPads damaged in a way other than bag or backpack, which is equal to probability that the first iPad damaged in a way other than backpack times the probability that the second damaged in another way other than bag or backpack, and so on 20 times for all 20 iPads. You might wonder, what is the 0.94? Where did that number come from? Well, 0.94 is 1 minus the probability iPad was damaged in a bag or backpack is 6%. 6% as a decimal is 0.06. The complement of that event, A bar, is 1 minus 0.06 is equal 0.94. Since we are multiplying 0.94 20 times, we can just raise 0.94 to the 20th power. It's equal to 0.290. Step 4. Find the probability of event A by evaluating 1 minus P of A bar. 1 minus 0.290 is equal 0.710. This result can be interpreted as, for a group of 20 damaged iPads, there is a 0.710 probability of getting at least one iPad damaged in a bag or backpack. Now let's learn about conditional probability. Conditional probability of an event is a probability obtained with the additional information that some other event has already occurred. P of B given A denotes the conditional probability of event B occurring given that event A has already occurred. The conditional probability of B occurring given that A has already occurred can be found by assuming that event A has occurred and then calculating the probability that event B will occur. The formula to find the probability of event B given event A already occurred is P of A and B divided by P of A. Let's look at the following example. Consider the table of pre-employment drug screening test. If one of the 555 test subjects is randomly selected, find the probability that the subject actually uses drugs given that he or she has a positive test result. That is, we need to find the probability of subject getting positive test result given that subject uses drugs. So we are only going to be looking at the subjects who use drugs. There are 50 subjects who use drugs. Out of those 50, 45 have positive test results. Therefore, probability of someone getting positive test result given the subject uses drugs is 45 out of 50, which is 0.900. We will use the same table to solve the second part of the problem. If one of the 555 test subjects is randomly selected, find the probability that the subject actually uses drugs given that he or she had a positive test result. Now we need to find the probability that subject uses drugs given positive test result. So we will be looking at only those who have positive test results, which is 45 plus 25, 70 subjects. Out of those 70 subjects, 45 use drugs. 45 over 70 is equal to 0.643 rounded to 3 significant digits. You probably noticed that the result from part A and part B is not the same. Probability of selecting someone with a positive test result given subject uses drugs is 0.900 and indicates that the subject who uses drugs has a 0.900 probability of getting a positive test result. Probability of selecting someone who uses drugs given that they have positive test result is equal to 0.643 and indicates that for a subject who gets a positive test result, there is a 0.643 probability that this subject actually uses drugs. Probability of selecting someone with a positive test result given subject uses drugs is not the same as probability of selecting subject who uses drugs given they have positive test result. This example proves that in general, probability of B given A is not equal to probability of A given B. There could be individual cases where P of A given B and P of B given A are equal, but they're generally not equal. To clarify the confusion of the inverse, let's look at one more example. Consider these events. Event D is dark outdoors. Event M, it is midnight. Is P of D given M equal to probability of M given D? Well, let's see. Probability that it's dark outside given it's midnight is equal to 1. It is certain that it is dark outside given that it is a midnight. The probability that it is exactly midnight given that it's dark outside is almost 0. Therefore, P of D given M is not equal P of M given D. Confusion of the inverse occurs when we incorrectly switch the probability values or think that they're equal. Coming up next, Chapter 4.4, we will look at counting methods, counting rule, factorial rule, permutations, and combinations. Stay tuned.